Hello again. So today we're taking a look at Concept 5, finding slope of a line. If you've not copied down the definitions from the textbook, I recommend doing that in your notebook now, and then press play when you are ready to hear some verbal explanations. All right, so the first thing we're going to talk about is slope. Slope is always represented by the letter M. So whenever you are answering a question about slope, it might be in the form of M equals and then whatever your slope is. Slope is referring to the change in y, so how your y coordinates are changing from one point to the next, divided by your change in x, so how your x coordinates are changing from one point to the next. Know that if your points are ever decreasing, well, that's a negative change, and so you would represent that with a negative sign. If they're increasing, that's a positive change, so you would represent that with a positive sign. So know that some of these numbers will be positive and some will be negative. Another way to approach slope is it's the rise of the line over run. So rise going up and run going left or right, and we'll kind of show you what that means here in a moment. You could think of it a little bit more algebraically as well, looking at 2 points on the line and subtracting the y coordinates divided by the subtraction of the x coordinates. Positive slope is when your line increases. So as you're reading your graph from left to right, just like you would read any textbook, you start from the left and go to the right. If your line increases, like you see in this picture, that's a positive slope. If the line decreases when reading from left to right, that's a negative slope. Vertical lines, like we've talked about in past concepts, are the lines x equals c, where c is like a constant number. Vertical lines do not have a slope. Their slope is undefined because they're just straight up and down. Horizontal lines, written with the equation of y equals c, they do have a slope. They're completely flat, so their slope is equal to a value of 0. The next thing I want to discuss is calculating slope. If you're given a picture of a graph and on your textbook you see the blue and red lines here, your textbook talks about this concept of rise over run by drawing these values underneath the line, but I often will draw them above the line when I'm going through it. What I mean by that is I'm going to start at the point, let's say I start here, and I think about how far do I have to rise before I then can run to the right, in this case, to get to the next point in my line. So you could draw out these steps of rise over run above the line or below the line. It doesn't make a difference. What you need to make sure that you do, though, is that when you write it out and you say m equals for your slope, that your rise is the vertical distance you have to travel, and your run is the horizontal or side-to-side distance you have to travel. Okay, and that you divide those two numbers. So know that you could visually kind of draw out those steps above or below your line, and you're going to end up with the same results. Finding slope from 2 points, and so this is what we're going to go through next. This is probably going to be what's least familiar to you right now, is finding slope from 2 points. So when you're not given a visual, but instead you're given points, how do you calculate the slope that way? And that's really the algebra side of slope here, is using this formula. So I will label this as finding slope from 2 points. So we're told point A is located at 15.8 and point B is located at 10.7. Now, when you're going through this, you always want to make sure that you're identifying which point is going to represent your first point and which point is going to represent your second point. You notice in the textbook they have what's called subscript, x sub 1, y sub 2, x sub 2, y sub 2. All that is it's saying this is going to be the ordered pair of your first point, this is the ordered pair of your second point for plugging them into the formula. I'm going to say A is my first point because I wrote it down first, and B is my second point. It really does not make a difference. You will always end up at the exact same answer, even if you switched around and said that point B was the first one and A was the second one. You're still going to get the same slope in the end. So I'm going to go through and label these. So I'm going to say this is x1 and y1. And that's a little hard to read, so I'm going to write those underneath actually. So this is going to be x1 and this is going to be y1. And then 10 is my second x point and 7 is my second y point. Using my formulas for slope, which is the second y point minus the first y point, divided by the second x point minus the first x point. So that means I'm going to take 7 minus 8 divided by 10 minus 15. If you're typing this into a calculator and you're typing it in all at once, I don't recommend it, but if you are, you have to have parentheses around these groups of numbers that you're subtracting. I do not recommend typing this all into a calculator at once because if you forget parentheses or you mess the parentheses up, you're not going to get the correct answer. So 7 minus 8 is negative 1. 10 minus 15 is negative 5. Doing a little bit of simplifying, negative 1 divided by negative 5, I have a negative divided by a negative, which means I really am dealing with a positive 1/5. So that is my slope. I know I have m equals at the beginning, but because I'm just kind of going to box my answer up here, I'm going to put m equals at the end as well. So my slope between these 2 points is 1/5.